Many systems, pretty much all systems, they are vulnerable to malware or malicious software. So this can be a virus or other types of software, which is aimed at gaining access to your system, stealing sensitive information like passwords, might encrypt your files, so they might turn your files into gibberish to damage your files. They might inject advertisement or other malicious activity. So that is always on the software level. So when we talk about virus, that is on the software level, so malicious programs that the user runs on their computer. So it's a host-based application. It doesn't run on your router, on your network, but it's really on your computer, on your host. And so that kind of can be run on your computer. For example, here there is two on the desktop. Now, of course, in the real world, those are not so obvious. When you install malware, they give it some other name. So instead of naming it malware, the creator of this kind of malicious software, maybe they rename it Word, for example, and they change the icon to look like words. Or maybe they name it to Internet Explorer or something like that. Something less obvious than simply malware. But the principle is the same. You install a malicious software on your computer, and once you run that application, that will cause damage to your data or steal your information and so on. So there is a so-called software, antivirus software, and that is an extra layer of security that looks for those kind of malicious programs if they exist on your computer. And usually they do so by scanning. So they scan your whole computer looking for those malicious programs. Now, and here we have a Windows XP box, and you'll see by default it's not running virus protection. So modern Windows systems, so XP and later, give you warnings about not running an antivirus software. Now, obviously here there is no antivirus software, so this computer is now vulnerable to malicious software and viruses. Now, any antivirus software works with a database. So behind the scenes, they use a database where they check your programs against the database programs. And if there is a match, obviously there's a virus. But it could be the situation where the virus that is created is not in that database. So then the antivirus doesn't detect the virus. But the principle is that they use a database behind the scene with viruses and then compare your programs to the database. So as I said, malicious software might gain full access to your machine. So on the left we have the target computer, the Windows user, and on the right we have the attacker computer, which is a Kali Linux computer. And here the attacker used a tool called MSF Venom to create a malicious program that will give full access to the target machine. It's called a reverse shell. And so the attacker will start listening for a connection. And I might enlarge the font here just to make it more readable. So malicious programs can be created just with one single command line on Kali Linux. You'll see just one command to create the malicious executable for Windows XP in this case. And here the attacker is listening for a connection. So it's listening for a connection. And now let's say the victim downloads the malicious program. So on the internet, downloads funny2.x is the name of the program. So they download funny2.x into, for example, their home directory. Then they start this program. So it doesn't seem to be doing anything on the victim's computer, but on the attacker's computer, you'll see now we are inside the Windows computer, Microsoft Corporation, Windows XP, and we can type the Windows command prompt commands and browse around the files. For example, we might list let me enlarge this. Might list the directory contents with the dir commands. So the attacker now has full control over the Windows computer using the terminal. Now, depending on the malicious program they create, they can now start webcam, they can take over the microphone or the speakers, they can restart the computer and do all kind of funny things. They can upload files to your computer, download, manipulate them, and so on. So all it took was one click on a malicious program to take over the computer. Now in this case, the attacker has full access to the target machine. There is also more dedicated software that steals information like banking information. There is malicious software that encrypts your files, so those are very infamous. Let me show you that. If we open the web browser here, and what it does, it locks all your files basically, and you can only unlock them if you pay some money to the attacker. And so that is called ransomware, and basically they lock all your files unless you pay money to the attacker. They might have malicious software that injects advertisement and other stuff. So we just demonstrated one type of malicious software now, which give full access to the target machine. So in this case, we were able to control the Windows machine just because the user started the malicious program. So let me align them nicely here. So if I exit here, start a listener, and you'll see that when they started this malicious program, we could then browse around the file system and do all kind of malicious things. For example, we can enter the desktop directory. Okay, there is no desktop directory here. Let's say the user wants to delete some files, so could say del setup, or everything starting with set, and you'll see now that file is deleted. So they can completely control the computer, which is one type of malicious software. That is where does the antivirus come in? So the antivirus software, they try to prevent the user gets those kind of programs on their computer in the first place. So it scans them either in real time or scans them once in a while, and then if such a malicious program is detected, the antivirus will delete that. So you'll see in this case there is no virus protection, so nothing gets deleted, but an antivirus software will delete or should delete such kind of malicious programs. In general, antivirus uses one or more of these techniques. So in this video, we'll go more into the static detection technique. It's also the simplest type of antivirus detection. So the way it works is, given a file, it's given to the antivirus software, and the antivirus software decide either it's malicious or it's okay. So just two possible outcomes given the file. Now, files can be really huge, can be really large on any system, and a file can be, for example, an executable or PDF file, a document file. Any type of file on the system can be malicious, and that is given to the antivirus software or the static engine. So as I showed you in the first one, static detection or the static engine is part of the antivirus software. So that is then given to the static engine, which is either malicious or okay. Then it checks that using an actual database. So it has a database of files, any antivirus software, and if the file is in the database, it is malicious. If it's not in the database, it is or should be okay. Basically, it's checking every file against the database, whether it's malicious or not malicious. So every antivirus vendor has a huge database of files, and those files can be malicious or not malicious. So how does this work? Files can be really huge. For example, you can imagine you download very huge files of a gigabyte or hundreds of megabytes. So what they do instead is to calculate signatures of files, and then they compare the signature of the file against the database of signatures. So that is a lot faster because the signature will always be short. So any file is just input, right? Is anything in the computer is 0 and 1, so input. That is then, the input is given to the signature creator, and the signature creator creates the signature, and then every signature is compared to the database. For example, you might have a database with several codes. So if a new input is given, they could check, is that input in the database? And if it's not a malicious. If it is malicious. So let's go back. Of course, we don't really need to worry about 0 and 1s. We just need to know that given the input, it's given to the signature creator. Synonym for signature creator is hashing algorithm. So computer science or programmers will often talk about hashing algorithms instead of signature creator, but it's the same thing. Then, of course, there's different creation programs or different hashing algorithms. There's 5, SSH1, and so on. So how does this work? For example, if we go to duck.com, we can type MD5 with any input. Let's say 5 hello world, and it will create a unique signature for that input. So you'll see if I zoom in here, it will create a new unique output and a unique signature, and this can be for any text. So for example, we type example, and it creates a signature for that input. So this input corresponds to this output, to this signature. Antivirus software will compare the signatures. You have to know that if we type a very long text here, so whatever, the signature length stays the same. So even if we have a very large program, they just need to check short signatures, which is fast. So MD5 was just one of the signature programs. You can use SSH1 or others. For example, SSH1 has different types of signatures. You'll see it's a bit longer, the signature length. So there's different signatures you can create depending on the input and the signature program that is used. So that is what antivirus does. Create the database. So basically the thing to remember from all of this is that every file is then turned into a signature, and the antivirus vendor checks every signature against their signature database. So that is the main idea with static detection. They just check the signatures against the signature database. We can try that ourselves with MAV. So let's do that. Nowadays there's lots of antivirus software, and all of them basically have similar features and work using the same principles. So what they include usually is a scanner. What a scanner does is scans your whole system, so either in real time or on demand. This can be through the graphical interface or the command prompt, but every file on your system, it's checking, is that file a virus or malicious, or is it not? So with every file, it goes through your whole system. Obviously that takes quite some time because you have many different files on your system, and then checks their database if that is a virus. So scanning is like the oldest techniques that exist from 1987. In those days, it was just command line only. Now many antivirus software have graphical interfaces. So that's one, and they have also different other detection techniques. They might have dynamic detection, which includes monitoring what the system is doing. They might have heuristic detection, so it's a more advanced technique that tries to see the behavior of programs and files. And of course there's signature-based detection, which is just like checking the case if or what kind of files are included. So that is detection techniques. So 3 different ones. So as I mentioned, it can be signature-based. So what does the program look like? It can be heuristic, so the kind of, and it can be dynamic, so checking the program in real time. We also, virus creators try to hide their program. So instead of distributing the program, they distribute, for example, a compressed archive like a zip file, a targz, 7-zip, RAR file, and so on. So that might escape the virus scanner because the zip file doesn't look like the program. For that reason, many antivirus software will decompress the archive, look in the archive if that is a malicious software, and does that for every archive on the system. So obviously that adds time to the scanning, but many antivirus software now looks inside archives as well. And there's other ways to hide code, so they might need to unpack different archives. Now some antivirus software includes emulators. So an emulator does further analysis on suspicious files. Instead of running the virus on your computer or the malicious program, they run it inside an emulator and then check what it is doing. So they can look in the memory, what files does it modify, what running processes does it influence, and so on. So some antivirus software includes emulators to look into the files. So there are some other common features that they can include, but it might not necessarily related to antivirus. For example, they might include a graphical interface, or some management console. They might include a firewall and stuff like that. So they might add additional security features that isn't necessarily about antivirus. Now there's many commercial firewalls, but for this course we'll use a free firewall, AV, just to demonstrate how this works. So we'll use this tool. You can download it. So if you go to clemav.net, click on download and click on alternate versions. And then you'll have versions for Linux. If you use BSD, for macOS, Solaris, so different versions of the antivirus software ClamAV for your system. That's clemav.net. And for example, if you were using Windows 32, you could then download the installer here. Depending on the system you use. For Linux, they'll tell you the install commands, or any system. So for example, Windows 64-bit. So if you have any newer version of Windows, it will be 64-bit. You can install the installer here. And we'll use this free antivirus just to demonstrate how the antivirus works. And this is a command line scanner, so it doesn't have any graphical interface. But for the purpose of explaining antivirus, that doesn't really matter, because we'll explain how it works. And so we don't really need any graphical interface. So download the antivirus software for your machine, so depending on which system. So that's clemav.net. Then click on download and then click on alternate versions. And you'll be able to select your operating system and then install it onto your computer. So let's create our own signature database. We'll use ClamAV for that. You can find it on clemav.net. Click download and click alternative versions. And then you'll be able to download it for Windows, Linux, or other systems, depending on what you use. Now, if you use a modern Windows, make sure to use Windows 64. So if you use Windows 10, Windows 11, any modern version of Windows, use the Windows 64-bit version. You'll see also if you use Linux or Mac, there's a version of ClamAV. So once you download it and installed it, it's an antivirus software. You can start creating your own database. So for example, here we have two files. I'm using the command line, but if I open a file explorer, you'll see we have funny.x and funny2.x, two programs. And let's create a signature for those programs. So this is very simple. We just type sigtool. Now, if you're on a Windows computer, that's sigtool.exe. Then your program, so the program that is used to create signatures. We could use MD5, and then the program name. So we type funny.exe, and then now we have the first entry of our database. It's the signature with the program name. So we copy this and save it. Then we can do that for any program, right, or any file. So we can say funny2.exe, another program which is in the computer. So we copy it and paste it. Now keep in mind it creates signatures based on the actual data, not on the file name. So if the attacker were to copy the file and rename it, for example, into anything else, let's say Notepad, and we calculate the signature on Notepad, you'll see that the signature remains the same. So we just renamed it, except of course the file name is different, but the actual signature is the same. So it creates the signatures based on the file contents and not on the name of the file. So you could copy this one as well. And that way you can create your own, sorry, not the commands, but of course the signature. And that way you can create your own signature database, your own antivirus software. You would calculate the signature for every file on your computer. Now to scan the computer for viruses, we can type clam scan. And then the directory you want to scan. For example, this is a Linux computer, so I'll type /home/kali. If you're on Windows, that might be / wherever you want to scan. So I'll do /home/kali, and that will do the scanning. It will check now signatures behind the scene and find out if there is a virus in the computer based on their signature database. So you'll see it scanning all the files and found 3 infected files. So you'll see it found here malicious software. So for example, notepad.exe that we just created, funny2.exe, funny.exe. So malicious software for Windows. So the existing antivirus database, or the database of ClamScan, already contains signatures for those files. That's why it could detect them. So if it can't detect them, you can add them to the program itself. So we can create our own database. It's the sigtool command, and then we can add that to our own database. So i.db, and you can add any program like this. Now I'm using a Linux computer, that's why I can forward the output to the file immediately. So I'll show you the file my.db. It might be that if you're on a Windows computer, you need to do this manually, and you can't write like this directly to a file. So I'll show you the file my.db, and you'll see now it added only one entry. So in Linux there is a trick to append to the file the output of the command, and you'll see this will create a database. So just a list of features and the file name, and of course we can do it with any file. And that will update our own database, so my.db in this case. And now what we can do is to use our own database with ClamScan. So we scan -d with our own database in the directory home/kali, which can be different on your computer. But -d, you can specify your own database, which is just a file with those signatures, right? So you can create those manually, those commands, you can copy those outputs and paste them in a file to create your own database. Or if you're on Linux, you can forward the output directly to a file. But as long as you have your own database with signatures and file names, then you can type clamscan -d, your own database, and the directory you want to scan. So in this case, home kali is on a Linux computer. That might be different on your computer. So if I press enter, you'll see I did a scan. The actual file has been, so let's just create a very short one, only one entry. So that overwrites the file with just one entry. And now let's try to do a scan. And you'll see it had some issue to load the database. But the main way virus scanner worked is by calculating the hash or the signature of the files and then comparing it with a database file. So a database containing all the signatures. For example, let's say we have some file here. Let's say we have funny.exe. So we calculate the signature on that. So either we can use sign tool for that. For example, sign tool -md with the file name. And then the antivirus program will check the signature, and does this signature exist in our database? And in this case it does. So we know that the funny.x is malicious. So of course the antivirus software does it automatically. Now if we were to do another program or another file, let's say my.db, you get another signature, and then the antivirus software will check, is that software in the database? No, it's not, so it's not malicious. That is the basic idea of how the antivirus software, or how the static detection, so keep in mind we use static detection here, how that works. There's other techniques to find viruses, but this is the one that all antivirus software has, is the static detection. So calculate the signature of a file and check if that signature exists in the signature database. Now there are different techniques for detecting viruses. So in the previous video we checked in static detection, but there's also dynamic detection and heuristic detection. So different techniques. First method, dynamic engine. What it does is it inspects Windows applications. So actually looks into the applications and see how does this application communicate with the system. For example, how does this application communicate by Windows? It can also be sandboxing, so creating virtual environments. So not your real computer, but a virtual computer where they run the program and see what it actually does in that isolated or virtual environments. So that is the dynamic detection method. So the drawback of this method is of course that the antivirus software will then run the malicious software, even though it's inside the isolated environment. But the malware developer might make it so that the antivirus or the virus program doesn't work in the isolated environment. So it's not a perfect method because it's a sort of a cat and mouse game between the antivirus company and the antivirus or the virus creator, and they will try to not make their virus not be detected in the isolated environment. But this is one technique that is used as well. And there is the heuristic method, which is the most common in today's modern antivirus software. So this heuristic method, they try to take a look at inside the code and every step, what is the virus doing based on the behavior of the program. So using certain rules, they can decide based on the behavior rules, is it malicious or not malicious. So different engines. Of course, we're not going to put an isolated environment in this course or some very complicated things. We just did static detection. But there are just different techniques to detect viruses. So ultimately, it is antivirus software, and there's different ways to detect them. So one is using the signatures, but you might create virtual computer software that runs the virus inside that virtual computer, and that way try to detect is it a virus or not. So, of course, different techniques. Static detection is the oldest way to detect and the most simple one. So there is different. Antivirus consists of different components or different engines. Usually they have static detection or almost all of the cases, and depending on the antivirus software, they also have dynamic and heuristic detection. But the final result, of course, is the same. So either it is malicious or it's not malicious. And the techniques that they can use to detect, of course, can be different. So it can be based on behavior, it can be the file signature, or they can simulate or actually run the virus inside a virtual or isolated computer and see is it a virus or not. So different techniques can be used, but ultimately the process is the same. So given a file, is it malicious or not malicious, will be the output. Many antivirus vendors have their own database. So as you saw in the image here, every antivirus software uses a signature database. And some of these databases are public. For example, on virustotal.com, you can upload a file and check if that file is malicious. For example, we can upload funny.exe and it's checking a hash, confirm update, upload. And you'll see it takes some moments, but it already calculated the hash here. and now it's checking whether that file is malicious, and of course it is a malicious file. So you'll see different companies and what is the result in their databases. So in this case, some of the antivirus databases tell that it's malicious, and others they might not tell. So this is also how you can evaluate antivirus software. You can check their databases with your own malicious files, or with malicious files that you accidentally downloaded from the internet, and see which vendors detect and don't detect. So in this case, there's quite some antivirus software that doesn't detect these malicious programs, whereas others do. So that's how you can see, like, okay, maybe this antivirus software is better than the other. When you check with a lot of viruses, you can evaluate which viruses, which companies or products detect the virus and which products don't detect the virus. So we can click on details and we can find the, you see the MD5 hash that we used before, and remember there's different programs to calculate the hash. So let me zoom in on this. So different hashes or different signatures. There's different programs you can use to create your signature. So you could, given a file, you could create a signature using your signature creator, which is also called a hashing algorithm. So given a file, you calculate the signature using a program like MD5, SSH1, or any of the others. So you'll see there's many programs here that create signatures. So if you scroll down a bit here, you'll see we have MD5, SSH256, vhash, imphash, and so on. So different programs that create a signature. And it doesn't really matter which you use as long as your database is of the same type. For example, if you have a database of MD5 and you calculate your signature using hash, of course you won't find the database because it's a different technique to calculate the signature. So always use the same signature algorithm for your file checking, for checking your file and your database, such that the signatures match when they find a malicious file. So there's also a behavior tab here, which is not using static detection, but actually one of the other detection techniques. So on virustotal.com, you can do a scan with any file. And behind the scene, it uses different engines. So you saw that it's using the signature engine, but it's also availability of the malware of other engines. Another website you can use is called yotti.org. So virusscan.yotti.org, Jotti. And here you can search for a hash, for example. If we click search hash, we calculate the hash of a file. So let me clear the screen here. We have different files, let's say notepad.exe. Then we scan our file, or we create our signature with sign tool. In this case, we specify the MD5 hashing algorithm or MD5 signature program. We copy our hash. So note that the hash here stops before the colon. And we paste it in and see if the database finds anything. So in this case, it didn't find any malicious thing in their database. So if we click scan file, we can browse and just select a file and see if it finds it then. So now you'll see it's also using different databases behind the scene, like Sophos, CNET, Avast, Bitdefender, and all kind of programs to all kind of databases behind the scenes. So it's not just using, where is it? Not just using one signature database, but it's using many signatures databases of different companies, different antivirus companies. And that tells you, is it malicious or not malicious? So you can use this website as well. It checks all those places behind the scenes. And you'll see it calculates a signature. And strangely enough, when we calculated the signature using search hash, it didn't find any malicious activity. Or actually it did. So here we go. When we click search hash and we paste our hash, which is the same hash as this one, click search, it found that several databases found that it's malicious. And so you can use this website as well to check databases of other companies, whether the file is malicious or not malicious. We can create our own antivirus software. In this case, we'll use just a static technique for finding viruses. So given a signature database, our antivirus software will check whether it's a virus or not. Of course, you need some programming experience for this video. We'll create it in Python, a programming language. So if you don't know Python, this will be very confusing. However, what we'll do is to create our own scanner, go through the files in the system, and then create signatures from those files and check those signatures against the database. So we can use any editor. For example, we take Notepad here and we'll write the actual program. So what we'll do is we'll import a module called OS. Let's do all kind of things on the system, operating system module. Then we'll create a directory list using a function called listdir, which is part of the OS module, with the path, for example, the default path, and then let's output it. Save this program. I'll call it test.py, or let's give it a normal name like antivirus.py, av.py. Next, we'll run it, and you'll see it lists the files in the current directory. What we can do next is loop over every file. So for file instead of dir list, we're gonna name it file list. So file underscore list, and we're not gonna output it immediately, but for every file in file list, we will output the file name. So this program doesn't do anything more than showing you the file names one by one on every line. So you'll see every file in the current directory, and what we want to do is only scan for executable files, so only the .exe files. So we can say if .exe in the file name, then outputs the file name. So now if we run it, you'll see it only scans for executable files. Next, what you want to do is to calculate the hash or the signature for every file, right? Because in our program, we use a signature database, and for every file we need to create For every file we need to create and the signature is then checked against the signature database. So we need to calculate the signature now. So we can use the hashlib module, which contains all the signature functions. And let me import that. So let me see if it's installed. Okay, if it's not installed, you can install it with pip. Install hashlib into your system. So with hashlib, we can calculate the signature of a file. So you can do that like this. Now this looks a bit cryptic, but this is how this module works, the hashlib module. So what it does is, given the file input, it calculates the signature. So you'll see hashlib.md5, which is one of the signature programs. So remember, we can use MD5 or any other signature algorithm. And then calculate the signature. So what the last line does is output the signature. So when we run this program, you'll see every program, based on the contents of that program, it calculates the signatures. And then what you want to do is, of course, check it against the database. Either you can do that with online database, like the ones you saw in the previous video, or you can check it against your own database. So we might create our own database in the program itself. So we might define a database here with all of the hashes of malicious programs, or all the signatures. Let's find some signatures. Maybe they list some on this website. Okay, it is super slow, so let's create some other signature. Let's say this one. And we need the signature. Okay, so now we have a very simple database of 2 entries. Now, of course, this wouldn't be an effective virus scanner because it would only be able to detect 2 viruses, right? Only 2 entries, only 2 signatures. Of course, in a real world application, you want to have hundreds or thousands of signatures of every virus. So now what you would do is check. So we could create a function that checks whether it's a virus or not. So check, give a signature. So if the signature is in the database, we output that it's malicious. Okay, so now instead of outputting it to the screen, we store it. And then we check the signature. So check with the signature. And then for every file, so for every executable, it calculates the signature and checks the signature against the database. So here it checks the signature against the database. If the signature is in the database, it's malicious. So very simple virus scanner. If we run it, you'll see in this case, it didn't find anything. So let's see why that is. So what we can do is to print the signature just before. It might be that the signatures it creates are in lowercase and the others are in uppercase, for example, something silly like that. So in this case, it found several signatures, but the signature just isn't in the database. So that's why it didn't find it. Now let's add this one to the database. And now run it. So now you see it scans every file, and it found that the last file is malicious because the signature is inside the signature database. Now, of course, this output is not really very readable. So what we can do is to remove the new line here, so that not everything is on a new line. So looks a bit better. Of course, we don't need to, we can output the signatures, but we don't really need to. Outputting the signature here. So we can, for example, output it more fancy using this technique, or we could remove the signature altogether because the end user is not going to be interested in the signatures. They just want to know, is the program a virus or not? So if we run it, now it tells you the signatures and whether that file is malicious. So of course the end user is not interested in the signatures, so might comment that out. And now if we run the program, it will tell you, okay, the last one is malicious, but this output is a bit bad. So instead of doing it this way, we can parse the file name, add the file name, and then output which file is malicious, so, or which one or more files, right? So we output the file here, or the file name. Now if we run it, it scans the current directory and it finds one malicious file because the signature, so we hit the signature, but the signature was in the database. So if we output it, you'll see it's calculating the signatures, and this signature of the last program is in the database. So that's why now it finds the virus. So we made a very simple virus scanner. Of course, it's not a very good one because it has only 3 files it can detect, only 3 types of virus. And another problem is that it only scans the current directory, so only one directory instead of the whole system. It doesn't go into directories. But this is how a very simple virus scanner works, or the technique behind it.